Alright guys, tonight we are going to talk about sampling. Sampling is the heart of calculation and rendering for V-Ray Next, and it's going to be about 40 minutes of presentation, and we're going to do some activity also. So today you're going to learn how to work with the quick settings and adjust image sampler, anti-aliasing settings of our scene to get better render results and rendering times. So before we start, there are a few terms that we need to learn. And V-Ray is a ray tracing engine. That means it shoots rays and it tracks back whatever it hits, the information that comes back to the camera. It traces that information back. So where the V-Ray word comes from? V stands for Vlado, is the guy that wrote this engine back in 1998, 99. And ray comes from the ray tracing. So ray tracing engines shoot rays, collect data on what each pixel should look like in the final render. So we got two types of rays. Primary rays, it shows from the camera scene, determine what's visible in the final image. So the first ray that goes from the camera, it hits the objects, and then from that it becomes a secondary ray. Secondary ray are shot from the end point of the primary ray to calculate shading effects. Sampling gathers information from the rays, determine what each pixel will look like at the end of the render. So sampling is basically we're taking a pixel and we start to divide it, we start to break it down, and that's that process called sampling. Anti-aliasing controls how information from the primary rays combined blended in order to produce a cleaner, noise-free image. Alright, so here we have a diagram of how this stuff works. And in order to understand better, we can see that we have the white rays are the primary rays. So the camera shoots, one hits the floor, one hits the shadow here, one hits the glass object here. And the primary rays, they're coming from the camera. They traced first, they determine what is in the scene, and then more rays, of course, gonna get better anti-aliasing. Secondary rays, shading rays, traced from the endpoint of the primary rays. So it hits, and then we start getting the secondary rays, and determine shading, reflections, refractions, translucency, and SSS, and global illumination, GI. So the primary rays, the camera rays, trace through a pixel grid to determine which parts of the scene are visible in the final image. The sampler compares information in adjusted pixels and traces more rays where the noise levels are too high. So for instance, if we have this ray shooting here to the floor and this floor is translucent, it's going to get much more rays in order to get this translucent floor in a really nice, good rendering quality. If depth of field or motion blur presented, primary rays are needed. Well, obviously, we gotta have primary rays in order to calculate the secondary. So if we look at the secondary rays, which are shading rays, we have the list here of those guys. So the shadows are the orange ones, so we can see this primary rays comes out of camera, hits that part, but that part is blocked by this box, and we have a lighting point here on top. So the light shines down on the box, and the box creates a shadow. So this is a rectangular shadow right here. If the ray goes out of the camera here, hits the floor, and then goes back, it hits that object, so it knows that there's going to be a shadow. Global illumination rays, GI. So you can see ray comes out of camera, hits the floor, and then it goes in every direction. That means GI being calculated. And we can see the GI actually continues. It hits the box, and then from the box it hits the floor, and it keeps bouncing and gathering and building those soft shadows. Reflection rays are those that's being reflected from the camera, so if they bounce off the floor, they will pick up and they will start throwing more reflections in different sides. Blurry reflection rays are those that being specular, or if we blur our reflections. So here we can see that they're getting split here, and we're getting much more of them in the calculation. Refraction and blurry refraction. Refraction are those that you can see going through the object and penetrating and going out. So a regular refraction ray will go and penetrate the object, but the blurry ones will start to break down and create more of those in order to calculate better quality. So everything that is blurry probably going to have more rays. Subsurface, stuff like skin or something that is like a wax or candle, you can see it penetrates the object and then it goes in very different directions trying to calculate the translucency of that object. And the last ones is translucency rays. We can see one ray coming out of the camera, hitting the glass, and from the glass it starts to break down into GI, and we can see one ray going up. This is one translucency ray that goes all the way up to the light source, right? So this is mainly how those rays work. The primary will hit the object, and then the secondary will start to divide, break down, and create quality according to how many rays we throwing into this object. Quick settings allow us to quick adjust between the interior, exterior, and we can control the shading quality and the AA quality. So the presets for global illumination based on that scene type can create custom presets for those type of renders. Simple GI quality controls using by a slider, so we're going to use that slider in order to control the quality. Simple shading quality controls by a slider, so we have the shading and the AI, all of them, and the GI, all of them have the sliders to control the quality. So we're going to examine this in a second. Simple anti-aliasing controls switch between bucket and progressive mode, so we can switch here all the way below from bucket to progressive, and slider controls the AA quality. Okay. Now shading quality is the one here in the middle. Affects number of secondary rays, affects noise levels and shading, affects like soft shadows, blurry reflections, refractions, SSS, and translucency. Affect quality of GI in the primary engine is set to brute force. Doesn't affect anti-aliasing of geometry, edges, and curvatures. Doesn't affect the noise levels of motion blur and depth of field. Those are being determined by the AA filter. AA quality is the last one. Affects the number of primary rays traced. Directly affect anti-aliasing of geometry and edges, so everything around the contour line of the object is the AA filter. Directly affects noise levels, motion blur, depth of field effects, and indirectly affects the number of secondary rays traced. So obviously the primary ray will hit the object, and indirectly it will cause how many secondary rays will be created, and that's in the AA filter is going to be traced by the numbers of secondary rays for each primary ray. And under the hood, shading quality affects minimum shading rate parameter, controls the minimum number of secondary rays shading. Rays that are traced for each primary ray, higher values mean less time to be spent on AA, and more effort will be put into sampling of shading effects. Okay, so minimum shading rate will affect the number of minimum secondary rays that are traced for each primary ray. So the higher values of the shading somewhere here means that there will be less rays sent from AA filter, and more effort will be put into sampling, into really breaking down and dividing the image, the pixel. Okay, so here's how our sampler looks. This is the bucket image sampler here. So if we can take a look at this graph here, we can see that some pixels, each cell is a pixel, some pixels have more rays, have more division in it, so it will have more quality, and you can see it goes all the way around the parameter. The curvature of that object here will get way more sampling, and those that in the middle will get one. The minimum subdivs, they will get only one because they don't need that much, and the maximum will get 8. So AA quality affects settings of the bucket image sampler. The slider affects minimum subdivisions, maximum subdivisions, and noise threshold parameters. So 3 of those guys being determined by the AA quality. Minimum subdivisions determine minimum number of rays being traced for each pixel. So you can see some of them don't need a lot, so they get only 1. Maximum subdivisions determine the maximum numbers of primary rays traced for each pixel. So those that need better quality on the curvatures will get more sampling in this area. And the noise threshold, this threshold used to determine if the pixel needs more samplers or not. So the threshold, which is 0.05, if it's really low, then it's gonna throw more. If it's bigger, such as 0.05 here in example, it's gonna be way less. Okay, so the lower we go, the better quality we get, and of course the longer rendering times. But the image, each pixel will be really broken down and rendered in the quality. Main points: shading quality. Use this slider to adjust noise levels and shading effects such as soft shadows, blurry reflections and refractions, subsurface scattering, and translucency. Okay, so this is going to be our shading quality. AA quality, use the slider to affect the anti-aliasing of geometry, edges, and curvature, and adjust the noise levels and the blur effects like depth of field and motion blur. I'm gonna check it out in a second. Okay, so let's go open our Max, download the scene, and practice those examples.